Okay, so let's go to the actual processing of the images in this program. This is the folder. I call it this program insert deformation detection, but it's actually have a few more options. So this is the folder which you will saw when you will download the app. Of course, the program is written in Python, so of course you'll need to download the Python and install it. Here are the requirements which you will need to install to start with this program. This is some of the basics libraries which are in Python community. To install this application, we can just open this this file. Here we've got the description how to do it. So we're just typing in CMD Windows Terminal this first command, which will install it to the upgrade version of the Python installation program. The second one, it will install these requirements, and then we just type. Actually, you have to type first Python then create and this command will activate the virtual environmental, and then you just type this command and it will open the application. I've got this application already, so I can just type in this command here. You need to be on the directory of the folder of this program, so let's go it. Here we've got the virtual environmental activated, and then just go with this one, Python GUI.py. So this is the screen which you will see when you will start with this program. Here we've got a few options. I will explain that step by step. So basically, to start, we just need to push we need to just click it here, new image. Here we've got the information about first initialization. Here we can check it, all the images which we've got in our processing. So at first we don't have any images. However, when we create a new let's say new part of this processing, we'll have here the new information, about the new set. Here's the directory in the memory of your computer. We don't have any images, so here are just random numbers for this initialization. So let's import the first image. At first, we need to create a model which will allow us to process the insert images. This model will learn on the image with classes which I created by myself, and then it will use this learning on those images to apply to another image. It's actually it's managing the weights for the model. Well, let's do this. Let's do this, and we'll see it how it goes. So to import the image, we just go to import settings. Here we've got the settings of the import. The first one is to crop the image. If we want to just cut the image which are, for example, too big, or we want just a small part of this image, so we just go yes. Actually, on the beginning, when we were working with the searched image, we are not cutting the image. Then when we want to cut, we can just put here the number of the pixel from the left edge, here from the upper edge, from the right edge, from the lower edge. When we've got some images with known values, we can just change them to 0, which will allow us to process this image. Let's say yes. The first, we've got actually 4. It's actually more type of formats of the images. The first one is just simple text file. The second one is CSV. This one it allows us to process the much more images from TIFF to PNG to BMP to many others. And this one allows us actually to manage with geolocalized TIFF. If we want to get some images, some output which are in some reference system with the localization, we'll just use this. But at the beginning, to create a model, we use CSV. Let's finish, and let's import first file. In the folder, you will see it. There is DDD repository folder. I've got here some example data. So here we go to learning data, and this one is the values of the first image. And we see it, this small image. It's here we've got the shape of the image. It's 140 for 187 pixels. Each pixel is actually around 40 meters, so it's around 2 kilometers by 2.5 kilometers. The point which I use this image, it's that we clearly see that there is a small deformation in this part, and we've got many artifacts here, here, and here. And this image allow me actually to model, to learn where are the real deformations and where are the artifacts. At first, for the model, we need to pre-process this image to the parameters which will then go to the learning process. To do this, first we need to go to mask stacking. So the parameterization, it's actually goes for each pixel. We will take a small mask which we can define actually here. At default, we've got 3 masks with 5 by 5 pixel, 9 by 9, and 15 by 15. But of course, we can reset them, and we can just type the many others. Here we've got from 5 to 21 masks. less masks is actually useless for this processing because of the parameters for this model require a little bit more than 3 pixels, 3 by 3 mask, but then more than 21 it will be the effect from one pixel to another after actually even less pixels are very small. So this is the sizes which I use for this model. Let's go with the default one. So 5, 9, and 15. Finish. What we will do this process. Let's go check it. So we can see here the shape of the image. It's 140 by 187, and it's this process mask stacking. It's created 3 matrices with this length. This is the length of the each of the whole image with pixels from the whole image, and this is the sizes of masks. So this is like a 3D matrices. To create parameters, let's go here, because of those data, learning data, we go here, parameters. Let's go with default. Later on I will explain which all of the settings which you can set, but first we'll just go with default. Here we can see actually the process, how it goes. It's going pretty fast. Parameterization are done. Here we can see it, which parameters we are using. So in the mask we can try to detect the trend, and the trend is managed by plane. If we have a flat plane, and so it's checking the variations in that plane, and the real standard, like a standard deviation in trend created in that mask. Variance from the pixel. This process is try to detect the variations which are from the center of the pixel, from the center of the mask actually. Standard deviation is just basic standard deviation in the whole mask. Simply deformation detection for each class. At the beginning, my classes are actually set from artifacts to no deformations to deformations from 0 to 5 millimeters, from 5 millimeters to 10, from 10 to 20, and from 20 just lower than 20. So we've got 4 classes for the deformations, and this process is checking if we have deformations lower than those which are in classes. And next one is the second trend detection in the next mask size, and further on next processes. So we've got our parameterization done. Here we can check it the result of this. We've got parameters. it's actually 76 parameters. If we'll check it, it's actually 74 parameters from this processing, but one is bias, which are actually just matrices with ones, and the second one is the real image, which also need to be as a parameter. Also, we can check how is the result here. So we've got here our data, our parameters. Here we can set which of the set it's actually it's working at the moment. So let's work with this one. It will be our master learning set. Current model data set is 1. If we check it, it's master learning. To learn the model, we will need also a class image. So the class image I created by myself. For each pixel, I check it, what's the value and what's the pixels around this pixel to allow to actually for each pixel we need a class which will show this model which pixel is in which class, and then it can learn how the parameters works for each classes. This image it needs to be a little bit smaller because of the parameters when they working on masks. The masks actually cutting the edge of the image, because we've got the biggest mask is 15, and so the new image, the class image, it needs to be smaller by half of the biggest mask, and it needs to be an integer. So we actually start from 8. This image is 140 but by 187.